Hello everyone. So in this video, let's discuss problem C of Codeforces round 1007. Okay. So the problem says like in an Italian village, a hungry mouse starts at vertex ST on a given tree with n vertices. Given a permutation P of length n, there are n steps. Okay. For the ith steps, a tempting piece of permission cheese appears at vertex Pi. If the mouse is printed vertex PI, it will stay there and enjoy the movement. Otherwise, it will move along the simple path to vertex PI by one edge. Okay. Your task is to find such a permutation so that after all n steps, the mouse inevitably arrives at vertex En where the traps awaits. Note that the mouse must arrive at En after n steps, though it may pass through En earlier. So basically, the question is saying we have one tree. Suppose this is a tree and we are given this is a tree with n nodes and n minus 1 edges. Okay, and we have given two nodes like st starting node and ending nodes. We have to move mouses such that it starts from this node and finally ends at en nodes. And how the movement of the mouse is like, suppose cheese will appear for every n like steps, so there will be a permutation of n numbers. Suppose cheese appears first here, then it mouse will stay at this node. Otherwise, if there is a cheese in these nodes, then mouse will move one steps towards this node. So one step is this root node. So it will move to this root node. Like this, if it appears again cheese here, it will move one step towards it, so it will return back to its starting node. So like this, the movement of the mouse is, and we have to give permutation here, like 1 to n numbers should be ranging from 1 to n, such that after like movement, mouse should finally be ending at en nodes. Okay, so to solve this problem, basically we need to have some like good observation, like you have to deep dive. So first observation, let's see. Okay, suppose there are three nodes like 1, 2, and 3. Okay, and like starting and ending nodes are also same, and it is one only. Now, how what would be the permutation so that after the movement the mouse will start from here and end here only? One solution can be like 2, 3, 1. Like we put 2 first, so it will move to this node. Then 3, so it will move back to 1. And finally 1, so it stays in 1 only. So finally mouse reach like end up in EN node only. Another solution you can think of is like mm, 1, 2, and 3. Like you are first node is 1 only, so mouse stays here only. Then it goes to second nodes, and finally it return back to 1 as last node is 3, so it moves one step towards 3, so it reaches 1. Now there can be more also. Let's so these two permutations says a lot. Like you see the last node in one of the permutation points to the node which is ending. Okay, so somehow it gives us the idea that we have to traverse the subtree of this node first, and finally the last node we would put is the en node, like the root here we can say. This applies same for bigger trees also, like the trees are this big also. So we will traverse all node, like move the mouse such that it would reach at this level, like for subtree it will move and reach to this root, and for this subtree it will move, mouse will move and reach to this you can say the first height, and this is zero height. So last node, if you put this en permutation, it moves back to this node. So this is one observation, that you need to have the last node in the permutation, and your mouse should be at the first level if zero level is the en node level. Okay. Now, what would be the second observation? Second observation would be something like when st is not equal to en, like then how it will be. So suppose we have tree like this. Okay, now en is this node and st is this node. How will you move the mouse so that you should have permutation with all numbers 1 to n, and start from here and ends here. Okay, so the idea here is we should go level by level. Like we should first do the like movement of mouse in this subtree where starting node is there. Then if there is a node here, like there was one node, like one subtree like this, then we would traverse this level by level and finally this node, so that it will be moving in the direction of en, and also at last it will be at this level, so that at the end you will get to en level. So basically main thing is you have like some en and you have some st, like you have to do dfs at en and like find the path, what is the path going to st nodes, and start the dfs call, like basically the movement of mouse with the st going towards the en, like there might be some notes, right, which will like between that start and en. So you have to go level, last level first, then second last level, basically st, then the nodes which is between st and en traverse whole subtree comes back to this node, then traverse whole subtree comes back to this node. En can also have other subtrees, so it can from here it can go to his sub, like other subtree, and at the end it should traverse back to en. So that is the whole like observation for this question. So if I show you the code, it would be much clearer what I mean here. Okay, so I inputted n sten. I clear the adjacency matrix. I have u and v. I am putting u and v like the way we do for tree adjacency matrix, u to v and v to u. If n is 1, the answer would be 1. So you don't have to do anything. If starting node is equal to the en nodes, as I explained there, like we have to do the DFA starting with the starting or en log, and we have to maintain a stack to trace back the last node visited. Okay, like as I was telling here, we have to go somehow to this node, right? So we should maintain a stack where we'll putting the node here with the ending time, like last ending node. So I pass in this DFS answer. Visited array. Okay, I will explain visited array in a minute. So this is a simple DFS for in child in density current. If child is equal to parent, we don't continue. Otherwise, we call a DFS on child. At the end, we will push that current node in our stack. Okay. This visited array I added because for this example, like when we are moving up, suppose we are at ST node. Now, like this, I don't know. If this is ST node and this is EN, when we do the DFS for this node, we might do DFS for this subtree also, right? We don't want to do like we have to go level by level. So and like visited array, like when we're doing the DFS, shouldn't visit this sub array again. So when purpose of visited array is we need not have to visit again this below subtree, and we have to pass the parent so that it don't go towards like for this if you are doing the DFS it shouldn't go up towards the EN direction. Okay. Mm, okay. Here first I find the path. So I call DFS on EN. Okay, ending node, and I store parent of. I do a normal DFS and I just store the parent so that I can start from like starting node and goes one by one above, and while going up I will put my node in path. So I just find the path here. So path it will be from starting towards the end. Okay. Now I will do the same thing with path like DFS of answer, and I will do like add in our stack. At the end we have to like reverse our stack, like put in a vector the stack value because stack is last in first out, so we have to reverse the answer and just print it. Yeah, that's all for this solution. I hope you understood it. That's all. Thank you.